Here is a problem for parametric equations. So in general, whenever in calculus and algebra starting, we have a graph in the two-dimensional. We write y is equal to f of x, right, as the equation for the curve. But not every single time we can do that. There are some graphs where the whole equation cannot be written. For example, x squared plus xy plus y squared is equal to 1. In this equation, it's difficult to write y as a function of x. Instead, we have written f of x and y as some constant, right? So this equation is more into this type because sometimes we are not able to write y as a function of x always. There is another way of writing the functions for a graph. These are called parametric equations. In parametric equation, each variable, two-dimensional x and y, each variable can be written as a function of some third variable, let's say t, right? In some real-life application examples, t can be considered as time, and mostly it is time, but some other problems it can be something else, right? T is usually belongs to some real numbers interval, right? I is some interval. So here is an example. I'm going to show you how the parametric equation relate to a graph. So this first question says, sketch the curve with parametric equations. X is equal to 1 minus t square, y is equal to 2t minus t square. So to draw the graph, the best strategy is first draw a table of values. So you can take some t values. T values are from -1 to 2. So I'm going to start with -1. Say take 0, take 1, and say take 2. And find both x and y values at this t. So x value for -1 would be 1 minus -1 square would be equal to 0. Y value would be 2 times -1 minus -1 square would be -2 minus 1, that's -3. When I put 0, 1 minus 0 square would be 1, and this would be just 0. When I put 1, 1 minus 1 square would be 0. 2 minus 1 square would be 1. 2, 1 minus 2 square would be -3. And 4 minus 4 would be 0. So we have these points. So at -1, the point xy point is 0, -3. At t0, the point is 1, 0. At 1, the point is becoming 0, 1. These are xy coordinates, right, on the points on the graph. And the last one is -3, 0. Let's try to plot this on a graph. So we have this grid. First point 0, -3. So x value is 0, y value is -3 here. So let's say this is -3. This is my first point. T here is -1. Okay. Take a note of that while you plot the point. Next value is 1, 0. 1, 0 means x is 1 and y is 0. So let's say this is your point. Okay. Let's say this is 2, this is 3, this is 4. -1, -2, -3, 1, 2, 3, 4. Okay, so our points are here. Next point is here. Next, 0, 1. X is 0, y is 1. And lastly, -3, 0. X is -3 and y is 0, right? Also note down the values of t. Here t is 0. Here t is 1. Here t is 2. Okay, so we're going to join the graph. So the graph is going to be starting from -1. It's going to go like this roughly. Okay, now one important thing, because t is going from -1 to 0 to 1 to 2 in this direction, parametric equation also not just gives the path, it also gives the direction of the path. So the point is moving from -3, 0 to, sorry, 0, -3 to -3, 0, as time is moving from -1 to 2. That's how you can say. So this is the graph of this function. with these parametric equations. Here is another example. Sketch the curve with parametric equations. X is equal to t square minus 3, y equal to t plus 2, with t's belonging to negative 3 through. Okay, so again, let's start with a table of values. We are starting with t values. We'll find x value and y value, and then we'll figure out the point coordinates. Okay, so t is from negative 3 to 3, so I am suggesting we take the, let's start with negative 3. So x would be negative 3 square minus 3 would be 9 minus 3, 6. And this would be negative 3 plus 2 would be negative 1. The point is 6, negative 1. Let's try negative 2. Negative 2 square minus 3. 4 minus 3 is 1. Negative 2 plus 2 is 0. The point is 1, 0. Let's try negative 1. Negative 1 squared minus 3 would be 1 minus 3, which is negative 2. Negative 1 plus 2 is 1. The point is negative 2, 1. Let's try 0. 0 minus 3 is negative 3. 0 plus 2 is 2. The point is negative 3, 2. 1. 1 square minus 3 is negative 2. 1 plus 2 is 3. So the point is negative 2, 3. 2. 2 square minus 3 is 1. 2 plus 2 is 4. The point is 1, 4. 3. 3 square minus 3 is 6. 3 plus 2 is 5. So the point is 6, 5. Okay. So let's try to plot this on our graph. I'm just drawing a grid. This is 0, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 4, 5, minus 6, 1, 2, 3, 4, 5, 6, negative 1, negative 2. Okay. The first point is 6, negative 1. X is 6, Y is negative 1. So the point is here. 1, 0. X is 1, Y is 0, 2. So also note down this is t negative 3. This is t negative 2. Okay. Then is negative 2. X is negative 2, 1. So this is your point. T is negative 1 here. Then we have negative 3, 2. T is 0 here. 1, negative 2, 3. This is your point. T is 1 here. 1, 4. X is 1, Y is 4. This is your point. Okay. T is 2 here. And lastly, 6, 5. 6, 5. T is 3 here. So we need to join the points. It's important that you join in, you can join in any way, but that has to be the direction. So if I join these points, so this point 2, 3, 1, and 3. Okay. So because it's going in the direction t negative 3, t negative 2, t1, t0, t1, t3. So the direction of the graph is here. It doesn't only give the path, it also tells you which direction your particle is moving.